Welcome to the Basic Foundation Physics lecture series. This is our lecture number 3, and in this lecture we are going to learn few more concepts of kinematics. The topics that we are going to cover in this lecture are motion under gravity and displacement covered by a particle in nth second. Whenever an object is in air, and if we neglect air resistance, then we say that the acceleration acting on this object is due to gravity only. Let's say a body of mass m is moving vertically upwards in this case, and in this case its velocity is downwards, and in this case its velocity is making an angle theta with horizontal. And in all these cases we are neglecting force due to air resistance, so we are assuming air resistance to be equal to 0. Since we have already assumed air resistance to be equal to 0, so in all these cases the force that will act on this body of mass m will be due to gravitational only, and its magnitude will be mg and direction will be vertically downwards. So force that will act on these bodies is mg and its direction is vertically downwards. So accelerations of these bodies will be equal to, we know that acceleration is force by mass. Force is mg vertically downwards and mass of body is m, so acceleration will be g and its direction will be vertically downwards. And value of acceleration due to gravity is 9.81 meter per second square. So whenever an object is in air, acceleration of that object is g downwards, irrespective of the direction in which that object is moving. The next concept that we have to study is displacement covered by a particle in nth second of its motion. We know that if the initial velocity of a body is u and acceleration of this body is constant, then in time t the displacement covered by this body will be equal to ut plus half at square. So this is the expression of displacement covered by particle from time t is equal to 0 to t is equal to t. First second of motion is defined as the interval of time from time t is equal to 0 to t is equal to 1 second. Similarly, second of motion is defined as the interval of time from t is equal to 1 second to t is equal to 2 seconds. Third second of motion is defined as the interval of time from t is equal to 2 seconds to t is equal to 3 seconds. So nth second of motion will be a time interval from t is equal to n minus 1 seconds to t is equal to n seconds. So if a body is starting with initial velocity u and acceleration of this body is constant, then in time t is equal to n minus 1 seconds, and it will cover a displacement as and value of time in the expression of displacement will be n minus 1. In n seconds, it will cover a displacement equal to s at time t is equal to n. So this difference is the displacement that is being covered by this body in n second of the motion. So the displacement covered by this body in nth second is equal to displacement covered by this body in n seconds minus displacement covered by this body in n minus 1 seconds. And we know that displacement covered by a body in the time interval from t is equal to 0 second to t is equal to t seconds is ut plus half at square. So displacement covered by this body in n seconds will be equal to u into n plus half a n square, and displacement covered by this body in n minus 1 seconds will be equal to u into n minus 1 plus half a n minus 1 square. So displacement covered by a body in nth second of its motion is equal to un plus half a n square minus un minus u plus half a minus b square is a square plus b square minus 2ab. So un and un will get cancelled, and half a n square and half a n square will also get cancelled. So displacement traveled by body in nth second will become u minus 1 minus 2n into a by 2, or u plus n minus 1 by 2 into a. So the final expression of displacement covered by a body in nth second of its motion is u plus n minus 1 by 2 into a, where u is the initial velocity of the body and a is its acceleration. Students are advised to remember this formula. If the body is starting from rest, so in that case the value of u will be equal to 0, and if acceleration of that body is constant, then displacement covered by that body in nth second of its motion will be equal to 1 minus n by 2 times acceleration of the body. If we substitute n is equal to 1, then we will get the value of displacement covered by that body in first second of its motion. So it will be equal to 1 minus 1 by 2 times a, and its value is equal to a by 2. And similarly we can also find the displacement covered by a body in second of its motion. So value of n here is 2. So 2 minus 1 by 2 into a, this will become 3 times a by 2. Similarly, the displacement covered by this body in third second of its motion is equal to 3 minus 1 by 2 into a. So 3 minus 1 by 2, 5 times a by 2. So from this we can conclude that displacement traveled by this body in successive time interval is in the ratio of odd numbers. Although we have proved this for a time interval of 1 second, but this is valid for any regular time interval delta t. So if initial velocity of object is 0 and acceleration is constant, then displacement covered by that particle in successive time intervals is in the ratio of odd numbers.